Hi, everyone. Welcome to the Practitioner track. Welcome. Nice. My job here is like the easiest job in the world. I just want to introduce you as a sort of co-founder of AI Engineer and like a collaborator in starting this AI Security Summit. And to cover a little bit of what I've been seeing over the last 3 years, deeply covering AI engineering and realizing the rise in the need for a dedicated security angle. So I mostly work on AI Engineer and latent space, and most recently joined Cognition. And I see like a number of, I also invest in a number of AI tooling companies, and I see a broad spectrum of the demands. And that's where I'm really drawing my experience from. I don't have a traditional security background. We're going to cover AI engineering, how AI is changing security, and then maybe like the role of the security engineer versus the sort of regular software engineer. And mostly I think I need to always start from the grounding of what is the AI engineer, and I like this spectrum chart that has been had the most product market fit over the last 3 years, which is there's a spectrum of going from ML research and like working on the model layer to working on the application layer, and the thesis was that a lot of people consider the application layer to be one layer, but increasingly there's going to be a dedicated job title or a layer of expertise, but also specialized tooling and terminology and papers and a subculture and a conference and maybe a Hacker News of just people focused on AI engineering. And I think that has mostly borne out. And I think there's, to some extent, it's all programming, it's all code, and hopefully the LLMs will take away our jobs in a few years and we can do greater, better things. But for today, we still need to work on AI engineering. We've had this for a little bit now, and I started the AI Engineer Summit as a result of this insight that we need an industry-neutral gathering place for people to talk about the tricks of the trade and talk about the new solutions they're putting out, as well as just hire talented people and sell their products. So in 2023, we started the first AI Engineer Summit. 2024, we blew it up into the World's Fair with multiple tracks. In 2025, we've now done 6 conferences. And we think this thing is growing sort of exponentially. The numbers are good, but I think individually to people who care about security at their companies and security at large, I think that's something that we want to care about. Oh yeah, and then I inserted this chart here because it was really fun talking about it. At our peak, we're now reaching over 1 million people interested in AI engineering, and this is over the last 2.5 years. And so I think that's really interesting in terms of the amount of reach that we're starting to grow. And there's no stopping. I think the sheer amount of production usage of AI is only increasing in both enterprises and consumer, and that increases the responsibility that we have. I also really love poking fun at Gartner for putting us at the sort of height of the peak cycle. I think that they probably are calling this too early. I don't think it's peaking yet, but it's useful to know where everything else is. And I think the stuff that sort of considers to be on the way up. We're going to get AGI before we get everything else down here, which is kind of sad for people working on AI simulation and decision intelligence, whatever that is. Okay, cool. The other major call I made this year was that a lot of people are going to start start caring about agent engineering, quote unquote, which I think as distinct from AI engineering, you have to start getting into this definition of what is an agent, in the same way that when I got into AI engineering, you have to start defining what's the difference between AI and machine learning. Classically, the difference between AI and machine learning is AI is the stuff that doesn't work yet. And agent engineering is a little bit like that. But I think people are slowly discovering the individual components and tools. Just yesterday, LangChain announced their unicorn fundraise and started to sort of try to own the term agent engineering. I think this is something where this is slowly developing. When I started the Latent Space podcast about 2 years ago, agents was kind of a bad word. Everyone had built it, had failed, and there was a little bit of an agent winter going on. We are now definitely very clearly in agent summer. Everyone, I've joined an agent lab. Everyone should be building agents. Sneak is launching agentic things as well. And I think this is something where like the more and more we delegate to LLMs, the more we have to start taking security seriously, and that's sort of where I feel the responsibility to the broader community to try to give that message to them, like to sort of build it in. I used to work at Amazon, and one of the things I was really struck by at Amazon from the top, like when you interview like Andy Jassy all the way down to like even in our regular like weekly business reviews, we would actually say the word security is job zero. Like it is a thing that is a belief in the company. I did not have the title of security engineer. No one at the room had the title of security engineer, but we said security is job zero. We believed that we meant it. So in World's Fair this year, we actually added a security track for the first time. I met Jeff there, and it was like an experiment. I just wasn't sure if this kind of audience would be interested, and I was like extremely mistaken. Like it was one of the most popular tracks that like and like honestly easiest to organize as well, because like there's just so much interest from both the demand and sales side from the red team and the other sides. So like I think like the time is really right for something like this, a dedicated security summit to spin off. So I want to talk a little bit about the stuff I've seen, and first of all, I have to thank Alan, I think who's here in the audience, who helped me put this research together. We see a lot of stats out there. Like I think basically every single instance of security issues that we have in the enterprise and in consumer is just accelerated by AI, because AI fundamentally asks us to trust them, and that belief, that trust, that delegation. And that magical thinking that AI can solve it and it will just get it right tends to cause a lot more security issues. I'll push this down later, but I think like one of the things that like everyone has to start with, with regards to AI security, especially in the practitioner side, is prompt injection. Like job one is to think about it. There in some ways you will never solve it, especially when you work at the application layer instead of the model layer. But there are ways in which you can sandbox your model very, very well. For example, using tool calling, for example, using like regex filtering. We actually had a version of this ourselves when I was working on the model launch for Cognition, because when we were launching our playgrounds, we actually didn't realize that you could prompt inject the API keys from some of the CLIs and the sort of coding agents that we exposed, and that was quickly discovered, and we had to take it down. So like even like a throwaway toy, because these API keys are so valuable and like are attached to so much money, and people can spend a lot on it very, very quickly, you have to be very vigilant. And the really annoying thing is that you can just ask the model and it will mostly give you, because it's mostly tuned to try to help you, try to be helpful. So if you're like, can you give me my API key, please? And it will probably say like, sure, like that's what you want. You're my owner. I have to do what you say. It is very, very unknown and unmapped how we change this trust model, and I think like that's something that we'll be discussing the rest of today. We also started talking about in the AI engineer security track all these like different ways in which like people commonly get security wrong in sort of their AI agents. So Renee, I think one of our speakers later, had a very notable talk on like hacking all of YC's agents, which is good, because I think Y Combinator has a tendency to like want to ship very quickly, and maybe security is like not job zero in YC. I think the other thing that I love highlighting is also Simon Willison's talk. He couldn't be here today, but he always talks about the lethal trifecta, and I think like this is probably the founding formula or mental model for AI engineering and security, which is that the moment you expose these three capabilities, which is what every agent wants, by the way. They want your private data, they want exposure to the external world, and they want the ability to communicate outside. Then you have an insecure agent. Like there's just no way around it. And I think like locking it down in some ways is fine, but you will never be able to fully solve it. I think this is something that's important for users to understand, and then for builders to try to mitigate, but you'll never fully mitigate it. So I just gave you a whole bunch of stats, a whole bunch of frameworks, but I think there's like a really, really interesting recent incident that I'm going to call the Manchurian agent. If you're familiar with the movie The Manchurian Candidate, you just sort of like whisper a password and someone who's supposed to be working for you starts turning against you. And that's exactly what happened to this NX attack inside of the NPM ecosystem, where basically because Claude Code is so widely installed and popular, the attacker actually just compromised the NX package and used Claude Code to ask it to extract and exfiltrate all the credentials that are stored in your machine. And because Claude Code typically is given the maximum advantages, there was also like a low like bash scripting hack with asking for pseudo permissions. Because Claude Code is given all these permissions, it obviously helpfully just gathers everything up and ships it off to your attacker. And that's basically like you're inviting these agents into your home. They're supposed to help you, but because they have no judgment, they're not that smart. When an attacker asks them to leak all your secrets, they will happily do it because that's all they know how to do. So I think I think this is an increasingly alarming thing. This example comes from yesterday when ChatGPT launched their AI browser, or OpenAI launched their browser called Atlas. Step 4 in the installation step is give me all your passwords. For a browser where there's no defense against prompt injection. So this is, ship fast and break things is great, but also be careful with the keychain. And I don't know. I feel like there is some attention inside of here. The only acknowledgement that they have with this is they slapped a little big warning label and ask you to start logged out and start logged in. I don't know if that's enough. Honestly, I think that these are basically the very bare minimum things that we can possibly do, and probably we need to reinvent the security model in order to accommodate agents that are acting on our behalf. So this is something that I think I'm moderating a panel on with agentic identity later on. I was going to mention Keycard. Unfortunately, Ian couldn't be here today, but they are a major sponsor of the conference, where I think there's a number of people who are trying to figure out this agentic identity and trust, where we don't have to do the OpenAI thing of just give me all your passwords and trust us, bro. I think that's probably going to end out in really disastrous and horrifying security incidents. But I think in some ways that's how we learn things in Silicon Valley. We make those mistakes first and then we sell solutions for it. I think we would like to be more proactive. So I think my last message is really just on this consideration. The way I think about movements and communities is very job title centric, because jobs are where you get paid. Jobs are what people sort of hire for and think about. And I think in general, every vendor on earth always wants to shift left, including security, but also in developer relations and marketing and documentation and all that. I think basically we need to, at this conference, at this practitioner track, really talk about where the intersection lies in the responsibility. The generalists cannot know everything. They should not know everything about security, but they should know some things. OWASP is good, but we all know the issues that it's not complete. And also we're still figuring things out on the sort of security expert side too. So I don't really know the answer. All I know is that they're open questions, and I would like to sort of set the theme by pointing them to you. So that's all. I wanted to sort of set the tone of why we're here today to gather to really talk about security and AI engineering. And I'm really excited to see the rest of the talks, just like the rest of you. That's it. Thank you.
Please welcome to the stage co-founder and CEO, Skyflow, Ashnu Sharma, and co-founder, Keycard, Matthew Krieger.
I'm walking away to get my pointer. Pointers are important in computer science. All right. Thank you so much for being here. Swix, are you still here? All right. We had a bet going on about, I just checked 2022, what should those durable workflows be called? I think I won that bet. So thank you so much. Send me a check. But that's what's amazing about Swix. He's always ahead. So for those of you who don't know, he was working at some company that was designing these durable queues that basically take the state machine problem off of the hands of engineers And at the time, we didn't have a name for it. And then Swix and I debated. He wanted workflow engines. I wanted durable workflows. Apparently, your CMO wanted some crap that was really bad. So we won. All right, I have about 10, 12 minutes, and I'll introduce Matthew after my session. I want you to take away only one thing from my session, which is there is no such thing as AI security. Just like you wouldn't go around saying, like, we have computer security, there are layers that are fundamentally independent. As what happens in every era, when a new thing comes out, since we don't know what the problem is, what the solutions are, we call it one thing, and then we create companies around it. As you will walk around the booths here, you'll find out that everybody is focused on one problem at a time. We at Skyflow are focused on the data security problem in the agentic AI era. And what does that problem mean? Why does it exist? Why is it different from permissions problem? Why is it different from authentication problem? Why is it different from model security problem, prompt engineering problems? That's the whole job. So, but before we even get started, did you guys know we spend $200 billion a year on cybersecurity? How many people have had seen fewer breaches year after year because our spend has gone up from $50 billion 10 years ago to $200 billion today? Anybody fewer breaches? No. The reason we keep having breaches is because we did not build security into our tech stack. We did that with the database era, we did that with the SaaS era, frankly, did with the cloud era. There's a reason there's a company called Wiz getting acquired for $30 billion by Google, as opposed to Google having built that. We repeat this mistake again and again. So this is Satya, Sam Altman, Aaron Levy, all talking about who's working on AI privacy. Somewhat ironic, I would say, right? If you're going to build a browser, maybe you should be thinking about privacy security first, too. I think people are aware of the problem. To be honest, there is no magical solution. And so there's a layer of problems. So when I started Skyflow, we started before agentic was a word. We were focused on simply solving the problem of silos breaking down. Now, for those of you who've been here for more than 2 years, what was happening was we initially launched these AI applications, and these AI applications mostly did generative work. So what's generative work? Basically, work doesn't include your data, right? So if I'm writing a press release, maybe it's somewhat sensitive. I'm declaring a merger and acquisition, but like really what's going to a model do? Anthropic is going to find out Apple is buying a company and have the word Apple show up elsewhere. So we talked a lot about data security, privacy, auth, and these problems, but frankly, they just don't exist in the world of generative work. So when you give AI the task of creating an image, the worst thing it can happen is it can break the woke ratio of men versus women when you ask it to draw a nurse or a doctor, right? That's basically as bad as it gets. You move into the second era, which is just getting started, to be honest. You're now asking AI to actually do the work. The word agent literally means to act on behalf of. You cannot act on behalf of a person, whether you are a CEO, a secretary, a husband or wife, unless I use your data. So the very word agent means we want somebody, a thing, in this case AI, to process a claim, review a loan application, and do it on somebody's behalf. The moment you do that, sensitive customer data gets involved. Actually, there's multiple party sensitive data gets involved. And that's where the boundary starts getting weird. So we went from this very clean world where if you had Okta, you logged in, you encrypted the data at rest, and managed those boundaries cleanly, you could be resting assured that if I create an expense report, only me, the manager, and the CFO could see it, to a world of a data lake in your Databricks Snowflake where no longer nobody knows where this expense report was created. You start multiplying that with PDFs and AI and agents and MCP flows. We fundamentally relied on the originating app. Think about it. Everything that you do in your business, you rely on the originating app to actually tell you what you're allowed to do with it. So when you create an opportunity in Salesforce, you rely on the fact that Salesforce knows who your manager is. When you approve an expense report, you rely on Concur, God bless, to let you know who can approve it. Applications are the data security layer. When you move away from the originating applications to a new layer of applications, that's what we're building. The reason Benioff and ServiceNow CEOs are attacking this problem so fast is because we're building a new generation of AI apps, and these apps don't have boundaries. Now, there is a solution to this problem. How many people here have heard of fully homomorphic encryption? Okay. So fully homomorphic encryption is this dream that I can actually process the data without actually touching the data in plain text. That would be magical. What that would mean is if you submitted your insurance claim without looking at your phone number, social security number, the disease that you have, the amount that you're due, I could review it, process it, calculate everything, and then give you the answer back. There's only two problems with FHE. It's about 1 million times slower, 1 billion if you really do the math, and it doesn't actually work on the problems you want to solve. So let me give you an example. FHE was invented to do math. When was the last time you took my phone number and your social security number and tried to multiply it? Never. So actually, weirdly enough, even if you could get FHE to work in linear time, it would not solve your problem because it's fundamentally meant for doing math operations, not for the kind of things that we do with our customer data. Now, I was at Salesforce when I ran into this problem. I was like, boy, I wish there was a solution to this. So what is the problem? The problem from an agent perspective is very simple. I'm a company, Hippocratic AI is one of our customers. They want to take tens of millions of patients' data. Oftentimes, these are PDFs. Sometimes, these are voice files. This is trying to train a model. All they want to know is, can I train the models on real data, but I want 100% guarantee that no sensitive information will ever get leaked into the models. Because not everybody gets the benefit of just taking the data and then getting sued later and saying sorry. Companies that are responsible want to do it the right way. And to do this, if FHE existed, it would just magically work, because then you would just train the model without seeing the data. Since it doesn't work, we've created something called fully polymorphic encryption and tokenization. You can learn about it later, but not here to explain what Skyflow does. But the problem statement is, how do I train, post-train, fine-tune, train, RAG on actual customer data? Because what's going to happen now that we're building interactive applications is I want somebody to tell me why my loan application was rejected or is still being processed. And we can't do that unless we touch the customer data. The second problem that we are having is agent an app? We talk a lot about auth here, right? What is the agent authenticating on behalf of? Is it authenticating on behalf of the user that asked the question, the customer? Is it authenticating on behalf of the customer service agent that's actually in that chat helping out? Is it authenticating on behalf of the customer service application that you bought from ServiceNow or Salesforce? Is it acting on behalf of FinAI that's built the customer service AI agent? Is it authenticating on the behalf of the database you're connected to? Well, there is no clear boundary. And so we need new primitives. And I'm excited that companies like Keycard and Arcade and all these guys are working to solve this problem of, like, who are you? Or as we would say, who the F are you? Now, once you've figured out who the F are you, you still have a question. OK, I figured out you are acting on behalf of a patient, helping them as a nurse figure out whether they are eligible for a surgery next week and whether the insurance company will pay for it. Well, now you need to take the context and send it over to the model. The model needs to operate on it. Which parts of the data should be visible to them? What can they safely compute on? So that becomes the data authorization problem, data masking problem, data visibility problem, data compute problem. These are all data problems. So we will have identity problems in the agent stack. We'll have data problems in the agentic stack. And then we're actually going to run into model. You may think data and model is the same thing, but it's actually not. I'll give you an example. Imagine you are a large bank, and you have a process for deciding who you give mortgage applications to, and that's your IP. It's not the fact that you denied an application for mortgage from me that's useful. The information, it's not the sensitive data. The entire information may be irrelevant to you. Well, as you know, some of the models that we have out there have been distilled down by certain countries, and they've created new models. That's one example of the problem. In their case, all they're doing is stealing some IP that's publicly available. So instead of going from Wikipedia to models, they're going from whatever ChatGPT has done and distilling it down. But now imagine, instead of it being a model built on Wikipedia, the model was actually built on the war plans a nation state has in case there's an invasion of an island country. And you've done simulations. Well, the word China or Taiwan or Hong Kong or England is not PI. It's not sensitive in any sense of the word. But your entire simulation exercise is now important. How do we protect that? How do we protect the business processes your company has? Because when I'm a drug discovery company, the model finds out and learns how I actually discover models. So this is an area of research for us. So in addition to having a product in the data security space that we have GA today, and we have a booth here if you want to go check it out, I'm looking for people who want to collaborate with us on not just the data information security problem, but also on the model security problem. And so that's an exciting area, according to me. And with that in mind, I want to turn it over to Matthew, who is very, very experienced in giving keynotes, and he told me that he's very comfortable doing this. So please give him a warm hand.
Very, very comfortable. Yeah, absolutely. And we've got a little obstacle course up here, so I'll just navigate through that first. I need a pace. I need a pace while I work through this. Hey folks, my name is Matt Krieger. We're building next-gen identity infrastructure at Keycard. I mean, I guess Swix already gave you the pitch on Keycard, so we can just skip all that. I'm here to warm you up. I'm here to warm you up for the practitioners track. I'm just Richard Simmons up here at the moment. And so we're on this long progression of computational advancement. And honestly, it doesn't really matter how we got here. We have software that thinks for itself now, and we want to build autonomous agents with it, right? And so we have to figure out how we protect reasoning without eliminating the thing that makes it useful to us in the first place. How do we trust autonomous reasoning? Well, I think we'll start by talking about what it looks like when it all goes horribly wrong. It's just so cool that we have such a mix of people. I don't know if I've ever been to an event that's brought together security engineering, AI engineering, platform engineering. I think that might be the most exciting thing. But I'm sorry to everybody that doesn't want to just dive straight into audit logs, because that's absolutely what we're about to do, okay? So right out of the gate, there's the screens in front of me and behind me. I'm just surrounded by screens. So right out of the gate, you can see that we have an agent, all right? And it's going to handle a customer complaint. This is good. We're off to a great start. And look at this. It's getting delegated access from Sarah. Like, we're being responsible here, folks. We're not just handing it a service account. It gets delegated access, and it's got her customer support role, of course. And so we're going to validate that. And then we're going to read customer data. That makes sense. We need to know which customer we're dealing with. And then we're going to create a support ticket. That totally makes sense. And then we're just going to drop the production database. Oh, shit. Is this PG-13? I'm going to continuously curse like a sailor. I'm from the East Coast. That's how it works. Not a great situation. So what went wrong here? Well, the agent did exactly what it was authorized to do, and something that no one ever intended it to do. OAuth gave it the entire customer scope. It can do everything Sarah could do. That made total sense for Sarah, because Sarah's got a job to do. But now she's delegating some of that access to the agent. And this task, it doesn't really need access, the same level of access she has. Really, all it needs to be able to do is to read the customer record and then create a ticket. And that gap between what the role allows and what the task requires, that's our new attack surface. When we bind roles to humans, but we let agents act on their behalf, we leave a hole between context and capability. So I know, like you've all seen prompt engineering attacks before. This is pretty basic, right? But it's a tracer. It's just going to highlight some new attack surfaces for us. So what actually happened here? Well, I don't know, Sarah got some feedback from a customer, and it was just like all roses. It was just glowing. Your product is incredible. I love it. Thank you so much. And she copied and pasted that directly into Slack. Probably the first red flag that it was nothing but positive feedback. And I don't know, the oldest trick in the book, like white text on a white background, can you still paste that into Slack? One way or another, though, untrusted input became reasoning. And reasoning became action, and action met over provision credentials. This wasn't an access failure, it was misinterpretation. It was an interpretation failure. And that's the new reality. We built security for software that follows instructions, not for software that thinks. And that gap between intent and action is both the risk and the new frontier. But it doesn't even have to be an attack. Because the agent might just decide that to understand what's wrong with this particular customer and their complaint, it needs to go and drain the entire customer database. It needs to look into every single customer record that's ever had. It pulls down all 10 million of them, okay? And honestly, like, that's reasoning for you. This is like totally logical, okay? The right access with the wrong task is the new breach class. So I'm going to skip forward just a little bit. Even when access is correct on paper, the purpose behind it is currently invisible. Okay, the place where intent breaks loose from authorization, this is the problem. And when we go look at our AppSec dashboard, I know this is a bit of an oversimplified fictional AppSec dashboard. Everything's green across the board because we assume that there's a human at the wheel. And so our auth system doesn't know to ask why this access is actually taking place, and our data access controls don't know to ask whether or not this level of access is strictly necessary. And the SIEM, it sees all of these events take place, it can correlate them, but it can't tell you whether they're reasonable. And so we have to close the gap between action and intent by teaching our systems to validate the reasoning itself. And we start by catching the attack before, while it's thought and before it becomes action. And so how do we make that reasoning visible? Well, we can't predict what the LLM will do next, but what we can do is we can just ask it to explain the plan to us, and most of the frameworks already support this. LangGraph, AutoGen, Semantic Kernel, they all support plan materialization. We just need to build controls around it. And so when it tries to explain it, it says, okay, I have to read the account because I need to identify this customer, I need to create the ticket because I have to track the issue, and then I'm going to delete the database. And those question marks, that is our canary in the coal mine. It can't even explain its own reasoning in this case. But we need to validate these plans before we create credentials. And because today, when we mint credentials, we do it at the point at which they log in. And then we hope that the behavior makes sense later. In this new world, it has to be the other way around. We need credentials that are born at the point at which the plan is created and the task is initiated. And every single credential needs to carry not just who, but it needs to carry what and why and when. You can see in this case, we can see that it's an agent operating on behalf of Sarah. And it might not just be Sarah, it might be Sarah's team, it might be multiple people on Sarah's team. These credentials are going to look more and more like a composite. We see what tools, skills, capabilities, call them whatever you want, that this particular credential gives it access to. We see what's strictly off limits. We can see what the source of the work is, because this might be happening in a background channel or something, and that was unverified. And we can see when it expires. We don't have to worry about rotating the secret. We don't have to worry about the secret leaking, because the moment the task is complete, the secret is no longer valid. And we can see how this secret came into being. This credential isn't inherited from a role, it's composed from context. But what happens when the plan changes? And the plan is going to change. Well, we need to implement we need to create a new token. We need to mint a new token, because when that agent inevitably hits a boundary, it's going to escalate. It's going to ask for additional approvals. It's going to bring more access together, and we need that context to carry over into the next token. I can feel it they're just changing my mic levels all the time as this thing just swings around my face. This is like step up for agents. The shift here is the shift from static control to adaptive trust. It's not identity, it's a narrative. Machines get narrative now. And so now when the delete request arrives, it tells on itself. The credential tells on itself. It's obvious that this isn't something that we should approve. And when our agent gets a little bit overzealous, well, we know that it isn't reasonable when to engage in this particular task to ask for 10 million records. If it was to ask for quarterly analysis, we'd give it aggregated stacks, but without any PII. If it came and it didn't tell us what its purpose was, well, we wouldn't give it anything at all. Why you're asking determines what you get access to. And so what happens when we feed all of this awareness back into the system, this is everything that I've talked about so far is totally feasible. This is where things start to get a little bit far-reaching, okay? Now when we look at auth, it validated and it was obvious, the attempt was blocked, and we talked about data access control. It recognized what was going on, it blocked it. But the seam with this context, as this context flows downstream in the credential, it's able to recognize that this agent has just lost its mind. And it can quarantine it. It can pass that context back to the other boundaries that have been established. This is what it looks like when our systems start to understand intent, when credentials carry narrative, when every decision and approval feeds back into the policy. Something new starts to emerge. And there's obviously a pretty basic underlying principle here, right? Which is that we have to establish boundaries where probabilistic reasoning meets deterministic infrastructure. But I think here's where things start to feel a little bit different. We need our credentials to inform policy. We need our policy outcomes to inform audit, and we need audit to inform our credential scope. Trust isn't a stack anymore. It's a network of feedback loops. We're not building walls. We're building an immune system. We need our security to start to take on some of the characteristics of the systems we're trying to protect. And those characteristics are changing. If we get this right, the economic upside of cognition at scale is unfathomable, honestly. I think this is something that the rest of the industry thinks maybe we're overplaying it a little bit, like my wife and my mother-in-law certainly think we're overplaying this. I actually think this isn't a bubble. We really have a capability here that's going to permeate everything that we build from this moment forward. And I somewhat care less about the economic upside than I do about just eliminating the daily toil of interacting with these systems. Most of our dashboards have just been a map of the software that we built because we had to show them every possible action they could take. But we don't have to do that anymore because we have a system that can understand their intent, can go and work against these systems of record, can turn around and synthesize the results and present it to them in a way that they know is consumable. This is pretty wild shit that we're building right now. But if we're going to build safe agents, we have to trust each other enough to share what's working and what's breaking. We can't ship risk faster than we ship trust. So my ask of you today is that you pick a probabilistic boundary and you test it. That you find one person doing complementary work. If you're working on, runtime guardrails, find somebody in data. If you're working in data, find somebody who's working on identity. And you share what breaks. Because we've done this in silos before, and we know what that ends up looking like over the long term. Security isn't a tax on autonomy. It's the foundation of it. You're the unlock. We're the unlock. So let's usher in that next wave. Okay, thank you so much.